A major snowstorm buried parts of North Carolina and Virginia this weekend. In the Blue Ridge Mountains and nearby foothills, the snow is knee-deep and the roads are a mess. The storm is still pushing through the region tonight. Meg Oliver is there.
A snowstorm packing freezing rain, sleet, and strong winds blasted across the South. A winter wonderland arriving early before the end of fall.
In December of 2018, a major winter storm hit portions of the eastern United States. Although several states were affected, North Carolina received the worst of the storm. On December 10th, the governor of North Carolina declared a state of emergency as many parts of the state received close to 20 inches of snow, more than most of the state totals in a whole year. In the days and hours prior to the beginning of the storm, atmospheric conditions occurred that created a cold air dam in the western part of the state. This cold air dam enhanced the effects of the storm, leading to increased amounts of precipitation. There are different ways that a cold air dam, also known as a cold dome or wedge, can form. The classic precursor conditions occur when a high-pressure anticyclone is centered over the northeastern United States or southeast Canada, with a trailing tropical low-pressure system moving in from the southern U.S. or Gulf of Mexico. Cold air moves in a clockwise motion around the high-pressure anticyclone. This means air gets pushed in the south and westerly direction over the mid-Atlantic and southern areas of the East Coast. As the cold air moves up the slopes of the continent away from the coast, it slows down and becomes even colder. When this air mass gets to the eastern slopes of the Appalachian Mountains, it cannot overcome the mountains and becomes trapped. Often, as pressure is added to the system by continued transport of air into the blocked area, the cold air will turn and flow south along the slope of the mountains. This allows for the cold air dam or wedge to perpetuate southwards. When the warm, moist air from the low-pressure system meets the mountains and the cold air dam, it is forced around and over the cooler air. This causes what is known as an inversion. An inversion is an area of cold air that is covered by warm air. The advection of the warm air in the inversion causes it to saturate and release precipitation. The major problem with cold air dam events is the role that the cold air can have on precipitation. In many cases, the precipitation will begin to fall as rain, and as it falls through the cold air will freeze, resulting in sleet. Other times, the rain will not freeze, but become supercooled, causing it to freeze on contact with the surface, resulting in an ice storm. Another potential complication from cold air dams is in systems that are already creating precipitation. In this scenario, already saturated air is forced higher over the dome, creating more precipitation. This is what occurred in December 2018 in North Carolina. A low-pressure system that was already creating some snow encountered a cold air dam, and as it was forced over it, released the large amounts of snowfall in the central and western parts of the state. Predicting the results of a cold air dam event can be difficult. Historically, this phenomenon was not completely understood, resulting in unexpected disastrous storms. Recent advances in prediction technology and better understanding of the phenomenon has helped to alleviate some of these complications.